Hello everyone, and let me remind you of our Unit 3a goal. That is to describe relationships in data, and in particular, categorical data. We said in order for us to even look at that first, we need to be okay with the way categorical data is displayed. In the last video, we talked about bar graphs, segmented bar graphs, and mosaic plots. And now we're going to talk about two-way tables. All right, let's go ahead and check out page 5. All right, so a two-way table is a table that goes two ways. Let's give this a look. There are two variables that we will be looking at. Here is the first variable, and here is the second variable. Marital status and automobile classification. This one over here, think about this, goes with the columns. This would be considered our column variable. And the one that is rolling over on this side is going with the rows. That would be our row variable. Okay, it doesn't really matter which way it's organized at all, so that's that. Yay, check, check. Okay, the other things we're going to talk about are a marginal distribution. So remember, a distribution is just like a collection of numbers or a collection of your data as a whole. And so think about if you were on the margin, you're on this margin just means kind of like side, like the margin of the road is the side of the road. And so what we're going to do is just add up the totals for all of these things. So for instance, if you were to look and add up the sedans, for the sedans right here, right? So for the sedans, the 24 and 28, there's 24 for the married people and 8 for the single people. And so if you add that this way, this would be 32. And then if you did SUVs, that would be 36. Trucks would be 24. And then if you did the other kind of side, if you looked at this, we could add those together and figure out how many married people we had in our data. There'd be 66 married people. And if you added 8 plus 6 plus 12, that's 26 single people in our data. And so in total, it appears that we have 92 people. And so this information out here would be considered your marginal distributions. Now, there are actually two distributions or two groupings depending on the way that you're going to look at your data. This set down here would be called your bottom marginal distribution. All right, so that is for automobiles, right? That's one distribution of data that you could look at. You could see how those all compare, across the way. Or another distribution that you could look at would be this side. It just kind of depends on what you're looking at. So this would be the right marginal. And again, that's really going for marital status. So you can see, all right, how many people did you have in your data? How many people were married? How many people weren't? Versus this bottom one, again, was for cars. How many people had sedans, SUVs, and trucks? And how many people did you have in total? So I think we're kind of good with those. All right, so that's just being able to read a two-way table and just being aware that there's some vocabulary that goes with it. All right, so the second thing is we need to be able to answer questions based off of two-way tables. And so we have a series of questions down here, although I changed the data, so I was a little silly goose, but it's okay. So we're going to do the same thing. I have a set of data, and I also have a new column variable and a new row variable, and let's talk about those. So if I zoom in on this, it appears that our column variable would be size. And then our row variable over here would be flavor. All right. And maybe if you look, this is, instead of size, maybe we say height. So in this thing, we could kind of look to see, is there a relationship between how tall you are and the flavor of ice cream maybe you get? Or does the flavor of ice cream explain and predict how tall you are? I don't know. We're going to go through and see if we can just answer some basic questions about these. All right, first thing that we would want to do is find the marginal distributions. So let's go through and run with that. We've got think it's always very helpful to just put the marginal things on. So if we add these up, 12 plus 6 plus 9 is 27. So we talked about 27 9 people, or tall people. 4 plus 15 plus 8 is 27. And so in total, we talked about 54 people. Or we could look at it a different way and be like, all right, how many people liked chocolate? Well, that would be 16. How many people liked vanilla? Vanilla is 21. And how many people like strawberry? 8 plus 8 is 16, and so one more 17. So again, we could kind of add those up and kind of feel, and that should add to 54 as well. All right, that looks good. Okay, so now let's go and answer these questions. So the first question says, under the condition that the person is tall, what percent of people like chocolate? Well, so that's just saying only if the person is tall. I don't really care about any of the short people. I don't care about the total. I only care about the tall people. And so out of the tall people, there are 27 tall people. And how many of them like chocolate? The liking chocolate part would have to go on top. How many of the tall people like chocolate? 12 of the 27 people like chocolate. And so that would come out to be approximately 0.44. And to answer that question, that's about 44.4%. So you'll see that the condition, if you have one, becomes the denominator in what you're looking at. So the condition is that they were tall. That can be reworded a couple of ways. Look at this. It says for the tall people. So that's the condition. It's just worded a different way. What percent of them liked chocolate? It says given the percent of people who like chocolate, or give the percent of people who like chocolate if they're tall. So you can kind of see those different ways that those conditions are all kind of coming up in there. And they're all the same question. All right, let's look at another way questions could be phrased. It says the phrase of generally tells you what goes in the denominator. So again, we kind of, let's look at this. What percent of all tall people like chocolate? So of tells me we're looking at tall people. Again, I don't care about the short people. I don't care about the marginal distribution. I only care about the tall ones, and I want to know what percent of them like chocolate. And so that would be like, oh, okay, 27 or 12 out of the 27 like chocolate. And again, we already kind of did that one. Just another way to word it comes out to be 44%. All right, so that's not bad. So the phrase of kind of shows you what's going to go in the denominator portion, and then what you're looking at is also hidden in there. You also could have questions like these. It says, give the percent of people who are tall and like chocolate. Well, that means that it has to be both of those things. And whenever you do that, you're just going to go point. So go point at the table and be like, okay, here's the tall people, and here's the people that like chocolate. The spot that is 12. And again, it's like out of the total. Out of all the people that we had, how many people like chocolate? Well, there was 54 people, right? So 12 out of the 54 people is of the people. So it's talking out of everyone. And so that would give me, I don't know what that percent is, so we're going to go find it. 12 over 54 is 0.222. Which would give us 22.2% of our data are people who are tall and like chocolate. It has to be both of those things. All right. It says find the percent of people who are tall or like chocolate. So they could be tall or they could like chocolate. So that tells me to go look at my table and find out those things. So let's just go look. Here are all of the tall people. And here are all of the people that like chocolate. And so if you can be one or the other, we're just going to take all of those and just add them up. So we could have 12 plus 4 plus 6 plus 9. Those are all of the people that are tall or like chocolate. And again, of the people tells me out of everyone I had, which was 54. Right, and again, that was from us kind of filling out that marginal distribution from up here. right? And so, oops, poopsie. Let's go ahead and find out what this is, because I don't know. If we add across the board, we would have 31 over 54. And then we can go find out what percentage that is. 31 divided by 54 is, I'm just going to change, 0.5741. So that would be 57.41% of our data are people who are tall or like chocolate. All right, so hopefully when you see that you have a condition of some sort, or this of kind of tells you that it's a condition, that tells you that you're going to have to cross out stuff and laser focus your attention on what that condition is. Who are we talking about? Who are we only talking about? And notice that changes the denominator. Versus some of these other things, we're still looking at all of the people, but you have to know where to look. If it's both things, you should be able to just point. If it's an or, you kind of have to look at all of the spots that could be and just add them together. So this is a two-way table, again, as we talked about. Hopefully we feel okay with some vocabulary that goes along with it, and hopefully we're okay with answering questions about two-way tables. We'll practice this later. See you guys.